And finally, we have come to the last exercise of this section, number 10. Let I be the closed interval 0, 1. We have to compare the product topology on this Cartesian product of I with itself, the dictionary order topology on I times I, and the subspace topology that I times I inherits from the dictionary order topology on R times R. That means we have to compare three topologies with one another. Which one is finer, which one is coarser, if they are even comparable. So we have to say all these things. We start the solution by naming the topologies. That way it will be easier to refer to them instead of every time writing product, topology, dictionary, all these things. Let the topologies in the given order be tau P, tau D and tau S. P stands for product, D stands for dictionary order and S stands for subspace. Consider this basis element B1, this Cartesian product of the closed open interval 0, 1 over 2 with itself, basis element in the product topology, and the point 1 over 3, 0 or in this new notation times 0, same thing, in B1. And now consider B2 to be any basis element in the dictionary order topology containing this point. Since B2 has at least one point with its second coordinate in this interval, whereas all the points in B1 have their second coordinates in this interval obviously, because that's how the set is, and these two intervals are disjoint. That is why B2 is not contained in B1. You are well familiar with these topologies by now. So you think of why B2 is like this. Okay, you do that part yourself, you will realize that yes, this is the case. And because of this fact, tau P is not contained in tau D, or we can say it more nicely like this, that tau P is not coarser than tau D, or tau D is not finer than tau P. Also, no basis element of the product topology is contained inside this basis element of the dictionary order topology. This is a vertical open interval whose two endpoints are these two ordered pairs. Okay, you already know these things because this tau D is the dictionary order topology. It's an open interval in that dictionary order. And recalling what type of basis elements tau P has, all those basis elements have some positive area inside of those regions. This, however, is a single vertical line. So no such basis element can be contained in this. And as such, the dictionary order topology is not coarser than the product topology, or the product topology is not finer than tau T. Hence, the product topology and the dictionary order topology are not comparable. Next, we note this: for any basis element B3 in the product topology, we are using different names, okay, so that we don't get confused with this one and the previous one. Okay, so we have taken B3. If you want, you can write B also, or B1 and B2, provided you don't get confused. But anyway, so we have taken a basis element B3 in the product topology, any basis element and any point x in B3. Then for such a basis element, there exists a basis element B4 in the subspace topology, which is the intersection of our square, that is I times I, with a vertical open interval, such that this B4 contains the point x and is itself contained in B3. So unlike the previous two topologies, now the subspace topology is finer than the product topology. But no basis element of the product topology is obviously contained in B4, which is again a vertical, this time not necessarily an open interval, but a vertical line segment. And the types of sets that we have in the product topology, which are basis elements, they have again positive areas, so none of them can be confined within a line segment, and that is why the product topology is not finer than the subspace topology. Combining this thing and this thing, we see that they cannot be equal. Besides the subspace being finer than the product topology, they are not the same. So the subspace topology is strictly finer than the product topology. finally, we already know that the dictionary order topology is contained in the subspace topology. That means the subspace topology is finer than the dictionary order topology. You recall how we know this. And additionally, from example 3 on page 90, you go and see what it is. We also found that these two topologies are not the same. So, just like this relation, we also have this relation, that the subspace topology is strictly finer than the dictionary order topology. So that's how we have compared all the three topologies with one another. And this is where the solution ends. So next week we are going to start the next section, which is on closed sets, closure subsets, those things.